in all sorts of special 3D cameras, as well as viewers, one of which is still in use today. In the 1950s, 3D came to the cinema in a spate of sensational and horror movies. You had to wear special glasses with one green and one red lens. But because the images were often out of alignment and ghosting, it never really caught on. In the late 80s, a system using liquid crystal shutters in the lenses was developed. It produced alternating left and right pictures 30 times a second, which the brain amalgamated into one three-dimensional image. But all of those systems required the viewer to wear special glasses. The holy grail, if you like, of 3D technology is a system which produces that 3D image without the special glasses. A hologram can do it, but you can't project it and you can't transmit it via TV. The 3D image is in the actual material. Well, now here in Hobart, a small Tasmanian company has patented a new system which produces a 3D image without special glasses. It's in its experimental stages at the moment, but it could be the start of something big. A Hobart inventor, Ross Stokel's first experiments with 3D were in still photography, using two standard 35mm cameras on a special mount to produce the 3D effect.
Well, all previous systems, starting with Charles Wheatstone in the early 1800s, used parallel systems of viewing to view the image. And I've taken that concept away and taken it back to natural vision. We look at a point, not two disparate points. And by converging those both with the cameras and with our eyes, we can reproduce exactly the image that was observable in actuality.
So the cameras are actually set on a slightly different angle. Could you see that?
Yes, they can move in relationship to vision, to a point of focus.
Ross has a large collection of 35mm slides he's taken around Hobart, and as with previous 3D image processors, his system works well with the viewer. Not only well, but sensationally well. The subjects really look as though they stand out from the slides. It's the sharpest and clearest 3D image I've ever seen. But what's more interesting is that the system also works when you project the slides onto a screen. Big problem is that two images are projected, and you've got to look at them in a certain way so that they join into one three-dimensional image in the middle. Unlike previous systems which produced parallel images for left and right eyes, in this approach the image captured by the right eye camera is projected onto the left side of the screen, and the one taken with the left eye camera is projected onto the right. Now, when you focus your eyes on the point where they cross over, which is called the gate, the left and right images merge into one perfectly three-dimensional image in the middle. Now, one way to make this a little easier is to produce a sort of a gate with your own hands like that, and make it so that you can see only the left image with your right eye and only the right image with your left eye. And then try and focus on an imaginary pane of glass right between your hands, and then the 3D image should come into focus between your hands. Okay? See if you can do it. Now, if you're having a little bit of trouble, you can always bring your hands back slightly or move them forward. The ideal distance for that image to come into focus is about 35 centimeters away from your hand. That's just over a foot, if you're sitting about 3 meters or about 10 feet away from the TV set. So give it another try. Once you've done it a few times, you can achieve the results without putting your hands up as a reference. You just have to bring your eyes in together to this focus point here without using a finger or your hands or anything else. It does feel initially as though you're just trying to go cross-eyed, but you're not really, and it works very well. I've done it a few times. It does leave the peripheral images there, though. Channel 6 in Hobart has been cooperating with Ross in a series of experiments that have produced high-quality 3D video images.
Now, at least this way we can get the cameras closer together.
Ross's system of aligning the cameras can be applied equally well to TV cameras broadcasting live or recording onto videotape.
Okay, let's do it.
So now, in a few moments, we'll be able to see the images that those two cameras have of me, and like the slides we saw before, you should be able to convert them into a 3D image.
That looks good, Iain.
Of course, a lot will depend on how sharp your TV reception is at home, but if you get a good picture normally and you follow the directions I gave earlier about making a frame with your hands and then focusing in between them, then you should be getting a 3D image of me. If you don't, and you tape this segment, then you can try it again later, because it does get easier when you've done it once and you know how to do it. We'd like to know how well you're receiving this 3D image, so perhaps you could give us a call or drop us a line, and we'll give you details of how to do that at the end of the program. As I said, this is an experimental system, and it's got a fair way to go before it becomes a commercially viable and easily operated broadcast system. But if you're seeing this picture in 3D now, then it is a minor breakthrough, because it's the first time that it's ever been done on TV without glasses.
Up next, keeping noise and cold out, but letting the view